Hey digital crew, welcome to Earth Science. This is going to be our first content video together, and we are going to be talking about graphing as well as the layers of the Earth and the reference table. So make sure that you got the guided notes packet, which should be in the Google Classroom, as well as the reference table, which you should have from the scavenger hunt that was posted last week. So getting started with the graphing aspect of where we're going to be starting today, we're going to talk about variables. So variables are something you've probably talked about a lot in the past in middle school. Independent and dependent variable. These are words that you should be able to find pretty quickly in your guided notes packet. So starting right on that first page, you should see both words and you will have to fill in on the skeleton of what's provided. So independent variables. The variable that is deliberately manipulated to invoke a change in the dependent variable. So in an experiment, it's the thing that you are actively changing. If you wanted to see the temperature change on how fast you're breathing, you would be controlling the temperature. So that would be the independent variable. That means that the amount that you'd be breathing, how fast, would be the dependent. It depends on what you do to the independent variable. So change in response to the independent variable. Again, going back to that example, you in the experiment would be changing the independent variable of temperature, and then you would be finding out the response to that temperature change in how fast people are breathing. Now we're going to take a look at some of the different types of graphs. So you should have in your guided notes a chart that looks similar to what I'm showing here on the left. So types of graph relationship. So we've got the word direct, where both variables increase. I'm just going to doodle a little bit in Paint to show you what that looks like. So if these are our, and excuse this for not being perfect, but if this is our axis, or our axes, right, here's your x, and here's your y. If both are increasing, the graph will look like this. So that would be a direct relationship. If we have an indirect or inverse relationship, that means that the independent is going to increase and the dependent decreases. So I'm going to use a different color for that. So let's shift to, we'll do that one in green, let's say. Why not? That one would look more like this. So for your box, for the sample graph, you can draw the indirect graph. So the green line. Now the cyclic one, and I'll start a new graph. Let's go back to black. Cyclic is a little different. Cyclic is a repeating pattern. So that one looks like this. Goes down, then goes up, then goes down, then goes up. And it continues that on in a pattern forever. And then lastly, we have static. Static doesn't change. So static is a flat line. So in each of those different sections, I'd like you to draw the appropriate graph. Now, once you know the relationship between your two variables, you can make a relationship statement. For example, with this first graph here, you would say that as time increases, your temperature increases. Again, that would be a direct relationship, but that is the relationship statement. As time increases, temperature increases. Here you would say something a little different. You would say, as time increases, your temperature decreases, an indirect relationship. So moving away from graphs and more towards Earth, we're going to start talking about the layers and just a couple fun facts. So first fun fact is this. Earth is not a perfect sphere. Earth is what we call an oblate spheroid. Well, what does that mean? That means it's not a perfect sphere. It's a little chubby in the center compared to the poles. So if you look at those two different measurements, they're very close, but the equatorial diameter, the diameter at the equator, is greater, right? 12,756 versus the polar diameter from pole to pole, it's 12,714. So it's not a perfect sphere. This is a shape showing what a really exaggerated oblate spheroid would look like, but that is generally the shape given it's a little bit chubbier in the middle. So another thing you're probably very familiar with are the different layers of Earth. You've got the crust on the outside, you've got the mantle just below that, you have the outer core, and then you have the inner core. Take a moment to write down all of these facts about these different layers, but we'll be spending some time looking at them more in depth later. The one cool thing to note though, and definitely we'll come back to this, is that we know about all these things underneath our feet, not because we've seen them. We've not seen almost any of it with our eyes. We know it because of earthquake data. So again, we'll get back to that later once we start talking about earthquakes and how they figure these things out, but it's cool to know that they figured out all these different layers by studying the earthquakes. This brings us to the esrt. Again, this is a document that was posted in Google Classroom along with a scavenger hunt. So if you could scroll over to page 10, you will find something that looks like this, although this is a little bit on its side. Oh, earbud fell out. So please find this and we will continue to look at it. So here we go. Here's the top part of it, and you can see here we've got these 4 different sections. We have the top part, the asthenosphere or the mantle. The crust is above that, the tiny little black line. Then you have the stiffer mantle, so also part of the mantle in green. The outer core, which is in yellow, and the inner core, which is made of iron and nickel. Now on the right hand side over here, you can follow my mouse, the density is shown. So if you look at all the densities, you'll see the numbers as you look from the top going down, they all get bigger. Things are more dense as you go down. So if you were to follow those different sections down with the dotted lines, and I can actually go back quickly. Ooh, just kidding. Here we go. So if we follow down these dotted lines, that keeps getting in the way, but if you follow these dotted lines down here, that will take us to these lines here. So we can talk a little bit about the graphs. So this right here, the green, again, we go back, this is the stiffer mantle. If we take a look, the stiffer mantle in terms of temperature goes from, well, here's our temperature curve, this black line, right? It's the actual temperature of these places. You just have to look at the dark black line on the graph and then read over. So if we're looking at this part right here where it touches the asthenosphere or the plastic mantle, you could see that on this dotted line it's about, what would you say, 2,500, 2,600 if you go over. And we could do the same for where it touches the outer core. So you follow this dotted line, you hit this black line over here, and you read the temperature, and it's about 5,000 degrees, and that is in Celsius. So it's pretty hot. You can do this for any part of the black line. It just depends on which part they're asking for in a given question. So they usually like to follow these kind of dotted lines, but they also might use something that has to do with depth. They might say, what's the temperature at a depth of 2,000? In which case you would go, okay, here's 0, 0 being the surface. You follow that to 2,000, right? Because here's all the depth readings at the bottom. So you'd go 2,000 and you'd just do the same thing. You'd go up until you hit the black line, and then you would read over. So that would be, what, maybe 4,200 approximately? So that is how you use temperature and depth in this bottom part of page 10. Now there is a graph that sits just above the temperature chart, and you can see here, right, this is the graph that is sitting right underneath the stiffer and outer and all these other labels. It's the same thing, and you can still use depth with this as well. But for example, let's use the stiffer mantle again. If we follow this boundary down, and they ask you, well, what was the pressure between the stiffer mantle and the plastic mantle, you would follow this dotted line down until you got to the black line, and you would find that the pressure is maybe like 0.2. Now that's in millions of atmospheres, so it might not sound like a lot, but we are in 1 atmosphere. That's what it's talking about. Atmosphere is the pressure we feel at the surface. So even though it's 0.2, it's 0.2 million, so it's still a lot. We could do the same for the boundary between the stiffer and the outer core. If we follow that over, it would be something like 1.4, 1.5. So that would be 1.4 or 1.5 million atmosphere. So folks, here are a few questions. You have 4 of them. I'd like you to pause the video. I know, pause it and answer these questions. All right. So after you did your work, here are all of the answers that you should have found based on using page 10. So if you're a little confused, you can always follow these backwards, or you can ask during office hours.